Welcome to the peaceful space of sleep-friendly science, where we can drift among the stars and witness the grand, silent ballet of the cosmos unfolding. Tonight, let your curiosity gently awaken as we trace the magnificent life story of a star. We'll journey from its humble birth in a cosmic nebula, through its long, shining existence, to its spectacular death as a supernova, and discover what it leaves behind for the next generation. Now, settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1: The Cosmic Cradle. Our journey begins, not with a bang, but with a breath. A slow, silent, cosmic exhalation. Let your mind drift away from the world you know, and travel with me now into the deep, velvet quiet of interstellar space. Here, the distances are so vast that light itself becomes a patient traveler. The silence is not empty. It is full of potential, a quiet hum of existence waiting to be stirred. It is a peace that has existed for eons, and it welcomes you. Imagine before you a ghostly veil, a tapestry woven from the thinnest threads of light and shadow, stretching for light years across the blackness. This is a nebula. It is not just a cloud. It is a cosmic cradle, a nursery where stars are born. Lean closer in your mind's eye, and you can see what it is made of. It is almost entirely hydrogen, the simplest and most ancient of all atoms, the very first breath of the universe. And scattered throughout this hydrogen, like fine iridescent dust, are the memories of other stars, long since gone. Tiny grains of carbon, silicon, and iron, forged in the hearts of giants and scattered into the void, now waiting to be given a new purpose. These clouds drift in a state of near-perfect balance, a gentle, slow-motion ballet that unfolds over millions of years. There is no hurry here, but an invisible force, a patient and persistent sculptor, is at work. This force is gravity. Do not think of gravity as a fall, as a harsh pull that brings things crashing down. Here, in the vastness of the nebula, gravity is a whisper. It is a gentle invitation. It murmurs to each atom of hydrogen, to each speck of dust. Come a little closer. Join the dance. And so, the dance begins. Over a span of time your human heart can barely comprehend, the whisper works its magic. Two hydrogen atoms, drifting near each other, feel a faint, almost imperceptible attraction. They drift closer. They are joined by another and then another. A microscopic gathering begins. Across the vast tapestry of the nebula, countless such gatherings are taking place. It is like the first, gentle condensation of mist on a cool morning, a slow, magical coalescing of something from almost nothing. The whisper of gravity grows a little stronger in the places where more matter has gathered. These regions, these denser threads in the cosmic fabric, begin to gently pull on their surroundings. The dance becomes less random. A slow, inward spiral commences. It is a gravitational cascade, but one so slow, so majestic, that it is utterly peaceful. A cosmic whirlpool, turning once every 100,000 years. You are floating alongside it, a silent witness to the very first stirrings of creation. You feel no force, only a sense of direction, a sense of gathering purpose in the cold and the dark. Let us focus our attention now on one of these gathering cores. A region that was, by sheer chance, just a little denser, a little more successful in its gentle invitation. This clump of gas and dust is now immense, many times the size of our own solar system, yet still diffuse, still a ghost of a thing. But its heart, its very center, is growing more and more compact. As gravity continues to squeeze this material inward, a new kind of magic begins. The particles, once free to roam, are now crowded together. They jostle and bump against each other, and this friction, this cosmic rubbing of hands, generates a faint warmth. For the first time, in the heart of this dark, cold cloud, there is a source of heat. It is not fire, not light, but a deep, internal warmth, a blush that begins to suffuse the core. The pressure builds unimaginably intense, as the weight of trillions upon trillions of miles of gas and dust presses down on the center. The temperature rises, from the near absolute zero of empty space to thousands of degrees. And then, something new appears, a soft, secret glow. This is the birth of a protostar. It is not yet a star. It is a celestial embryo, a promise of a star. Hidden deep within its dusty cocoon, shrouded from the rest of the universe, this new object begins to shine. It doesn't shine with the brilliant white or yellow light of the stars you see in your night sky. It shines with the deep, ruby-red infrared glow, a light of pure warmth. It is the glow of an ember in a cosmic fireplace, a heart that has just begun to beat. This protostar will spend tens of thousands, perhaps even millions of years in this protected embryonic state. It continues to gather material from the collapsing cloud around it, a disk of dust and gas swirling around its equator, feeding it, helping it grow. It is like a seed, planted in the fertile soil of the nebula, slowly drawing in nutrients, gathering its strength for the great effort to come. It is the universe holding its breath, a moment of profound and quiet potential. Drift here for a moment in the presence of this nascent being. Feel the immense, patient timescale of its creation, the gentle, persistent whisper of gravity, the slow, blossoming warmth in the heart of the cold. Here, in the cosmic cradle, there is no violence, no rush. There is only a slow, inevitable gathering, a patient transformation from diffuse dust into a dense, glowing heart. The first chapter in a star's life is one of quiet becoming, a journey from the diffuse to the defined, a slow awakening in the deep, peaceful dark. Section 2. A light is born. Let us remain here, floating in the warm, dark silence beside this cosmic embryo. The protostar continues its slow, steady work of becoming. The disk of dust and gas that swirls around it, a miniature galaxy in its own right, continues to rain down upon its surface. Each particle of dust, each atom of gas, adds its own tiny weight to the whole, a contribution to the immense gravitational pressure that is building at the core. Imagine the weight of 1,000 worlds, 1,000,000 worlds, all pressing down on a single point. It is a pressure so intense, so profound, that it begins to change the very nature of matter itself. The heart of the protostar, once just a warm, glowing ember, is now becoming a furnace. The temperature climbs relentlessly, from thousands of degrees to hundreds of thousands, and then into the millions. The atoms of hydrogen, which once drifted freely, are now packed so tightly that they can no longer be considered a gas. They have become something else, a plasma, a frantic sea of atomic nuclei and liberated electrons, all crushed together in an impossibly small space. They are a crowd in a room that is shrinking, the walls closing in, the pressure becoming unbearable. In this cosmic crucible, the hydrogen nuclei simple protons are pushed ever closer. They resist, a fundamental force of nature, the same one that keeps your hand from passing through a solid table, pushes them apart. They are like two shy dancers, forced onto a crowded floor, repelling each other's approach. But gravity is a relentless choreographer. The squeeze continues. The temperature soars past 5 million degrees, then 7, then 9. The dance floor shrinks. The music of the cosmos grows louder, more intense. And then it happens. A threshold is crossed. At 10 million degrees, in the very heart of this immense pressure, the resistance is finally overcome. Two hydrogen nuclei, two protons, are slammed together with such force that they can no longer repel each other. They merge. They fuse. In this moment of forced union, a profound alchemy takes place. One of the protons transforms, releasing a tiny, ghost-like particle that flies away, and it becomes a neutron. A new, heavier form of hydrogen is born. But the most important part of this transaction is not what is created, but what is lost. If you were to weigh the two original protons, and then weigh the new particle they have become, you would find that a tiny, almost infinitesimal amount of mass has vanished. It has not been destroyed. It has been converted. It has been transformed into a pure, brilliant burst of energy. A single sigh of light and heat equals mc squared. You do not need to know the equation. You only need to feel its truth. A minuscule amount of matter, multiplied by the speed of light squared, unleashes a torrent of energy. This first fusion is a single, tiny event in the immense heart of the protostar. A single spark, but it is a spark that ignites a fire. The energy it releases adds to the heat of the core, making it even easier for other nuclei to overcome their resistance. A chain reaction begins. 2 more nuclei fuse, then 16. The process continues, building upon itself, as hydrogen is forged into helium. The heart of the protostar, which for so long was only passively glowing with the heat of its own compression, has now caught fire. It has ignited its own internal nuclear furnace. The protostar has awakened. It is no longer an embryo. It is a star. A tremendous wave of energy, born from this new nuclear heart, begins to push outwards. It is a force of incredible power, a stellar wind made of light and radiation. For the first time, the star is not just pulling matter in. It is pushing back. This outward pressure slams into the remnants of the dusty cocoon that has shrouded it for a million years. The veil is about to be torn away. Imagine a giant, cosmic dandelion, its seeds held tightly in a sphere. And now, from its very center, a great breath blows outwards. The star is clearing its own nursery. It unfurls its wings of light and pushes away the gas and dust from which it was born. We can see it now for the first time. The dark, cloudy cocoon is blasted away, illuminated from within, becoming a brief, glowing ghost of itself before dissipating into the void. The young star stands revealed, a brilliant, blazing jewel against the black velvet of space. It has claimed its place in the cosmos. What happens now is a moment of perfect, sublime balance. The star enters the longest and most stable phase of its life, the main sequence. It has achieved a state of celestial equilibrium. The immense, relentless force of gravity, forever trying to crush the star into a single point, is now perfectly matched by the ferocious, outward-pushing pressure from the nuclear fusion in its core. It is a cosmic tug-of-war, with 2 titans of the universe locked in a perfect stalemate that will last for billions of years. Gravity pulls in. Fusion pushes out. This balance is the star's heartbeat. It is the rhythm that will define its long adulthood. This is the state of our own sun, a middle-aged, main-sequence star, locked in the same beautiful, life-giving balance. The new star shines with a light all its own. Its color depends on its mass, the amount of material it managed to gather in its infancy. Smaller, cooler stars glow with a gentle, orange or red light. Stars like our sun shine with a brilliant, steady yellow-white. And the most massive, most luminous stars, the titans of the galaxy, blaze with a fierce, blue-white fire, burning through their fuel at a furious pace. But for now, our star, this newborn point of light, simply shines. It has emerged from the darkness of its cradle, ignited its own heart, and settled into a long and peaceful existence. It pours light and warmth into the empty space around it, a beacon of energy, a constant presence in the vast cosmic ocean. Its life has truly begun. It has found its voice, and its song is light. Section 3. The long, shining adulthood. And so our star has settled. The chaotic drama of its birth has subsided into a long and profound peace. Let your consciousness drift here, in orbit around this beacon of light. This is the main sequence, the star's great, long adulthood. For a star like our own sun, this phase will last for 10 billion years. A span of time so immense, it is like a quiet, deep ocean. The lives of planets, of civilizations, of entire species, are but ripples on its surface. The star now exists in a state of exquisite, perfect grace. It is a master of balance. Feel again that cosmic tug-of-war we spoke of. Deep within its core, gravity, the eternal sculptor, continues its work, relentlessly trying to crush the star, to pull every atom into an infinitesimally small point. It is a silent, immense weight, a constant inward pressure. But from that same core, the nuclear furnace, born of that first ignition, pushes back with equal and opposite force. The light it creates, the energy it unleashes, is a constant outward breath, resisting gravity's embrace. Inward pull, outward push. For billions of years, these two forces will be locked in a perfect stalemate. This equilibrium is the source of the star's stability. It is not a static, frozen balance, but a dynamic, living one. It is the steady, rhythmic heartbeat of a celestial being. A slow, deep breath that takes 1 billion years to inhale and 1 billion years to exhale. This is the peace of a star in its prime, a quiet confidence that radiates through space. It is no longer gathering, no longer becoming. It simply is. Let us now journey closer, past the brilliant, blinding surface, and deep into the star's interior. We will travel through its layers as if we were thoughts, unaffected by the heat and pressure. The first region we encounter surrounding the core is the radiative zone. Here, the energy born from fusion begins its long, slow journey to the surface. And it is a surprisingly arduous journey. The plasma here is so incredibly dense that a photon of light, a single particle of energy, cannot travel freely. Imagine trying to walk through an impossibly crowded room where every single person is moving randomly. You take one step, and you immediately bump into someone, sending you in a new direction. You take another step, and you collide again and again and again. This is the life of a photon in the radiative zone. It is born in the core, and it leaps outwards only to be absorbed by an atom and then re-emitted in a completely random direction. It might travel sideways or backwards or just a little bit forward. It is a journey of 1,000,000 billion tiny steps, a drunken walk that stumbles through the dense heart of the star. A single photon, born in the core, can take over 100,000 years to finally escape this zone. 100,000 years for a particle that travels at the speed of light. That is the sheer density of a star's heart. As we drift further outwards from this dense, radiant sea, the nature of the star's interior changes. We reach a boundary where the temperature and pressure have lessened. Here, the plasma is no longer content to pass energy along in this slow, random way. It begins to boil. You have entered the convective zone. Picture a giant pot of water simmering on a stove. Hot water from the bottom rises, carrying its heat with it. As it reaches the surface, it cools, and then sinks back down, only to be heated and rise again. This is precisely what is happening inside our star, but on a scale that dwarfs all human comprehension. Great, churning currents of hot plasma, some larger than the entire Earth, rise from the boundary of the radiative zone. They are like giant, celestial elevators, carrying their cargo of heat and energy upwards at tremendous speeds. As they reach the star's surface, they release their energy into space, cool, and then sink back down into the depths to be reheated. The entire outer layer of the star is a seething, rolling, boiling ocean of light and plasma. It is a constant, powerful churning that you can feel as a deep, resonant vibration. It is the star's circulation, its lifeblood, ensuring that the energy forged in the hidden core is efficiently carried to the surface to be released as light. And now we arrive at that surface. It is called the photosphere, the sphere of light. It is not a solid surface you could stand on. It is simply the layer where the plasma has become thin enough for the photons, our patient travelers, to finally make their last leap into the freedom of space. After its 100,000-year journey, the light is finally liberated. The view here is mesmerizing. The tops of those convective cells look like bright, golden granules, shimmering and shifting in a pattern that is constantly changing, like a pot of boiling honey. From this surface, the star pours its soul into the universe. It releases a ceaseless stream of light, heat, and charged particles, known as the stellar wind. This wind travels out through the star's own solar system, creating a protective bubble, a sphere of influence that shields its planets from the harsher radiation of deep space. The light provides the energy for life. The warmth creates zones where liquid water can exist. The star has become a cosmic parent, a shepherd, nurturing the worlds that orbit it. It is a constant, reliable presence in their sky, the anchor of their existence. Its steady heartbeat is the clock by which they measure their days, their years, their very lives. And so it continues. For eons, the star will perform this one magnificent task, turning hydrogen into helium and turning the lost mass from that union into light. It is a vast, slow, and utterly beautiful act of cosmic alchemy. A candle, lit in the darkness, burning with a slow, steady flame. But even the most magnificent candle has a finite amount of wax. And the star has a finite amount of fuel. Deep in its core, with every fusion, with every beat of its heart, the supply of hydrogen is slowly, imperceptibly being depleted. For now, this change is of no consequence. But the process is relentless. The balance will not hold forever. The long, peaceful adulthood must one day come to an end. Section 4. The first signs of change. We have spent an eon, it seems, in the steady golden light of the star's long adulthood. The dynamic, life-giving balance between gravity and fusion has held for billions of years, a testament to the elegant physics of the cosmos. The star has been a reliable anchor, a constant sun to its orbiting worlds. But nothing, not even a star, is eternal. Change is the one inescapable law of the universe. And now, after 10 billion years of stability, the first signs of that change are beginning to stir deep within the star's core. Let us journey back down through the boiling convective zone, through the dense radiative zone, to the very heart of the star. For billions of years, this has been the site of a continuous, self-sustaining fire, fueled by an immense ocean of hydrogen. But that ocean is now running dry. The relentless process of fusion has consumed almost all of the available hydrogen in this central region. The core is now composed almost entirely of the ash from that long-burning fire, helium. This helium ash cannot yet be used as fuel. The conditions are not right. The temperature and pressure at the core, while hot enough to fuse hydrogen, are not nearly intense enough to force helium atoms to merge. And so, the furnace at the heart of the star begins to flicker. The chain reaction falters. The fire goes out. For the first time in 10 billion years, the outward push of fusion energy from the very center ceases. But gravity never stops. The silent, inward pull continues, as relentless as it has always been. And now, with nothing to push back against it, gravity begins to win the cosmic tug of war. The helium core, now inert and silent, begins to collapse under its own immense weight. This collapse is a pivotal moment in the star's life. As the helium core contracts, the pressure and temperature within it skyrocket to levels never before seen. It becomes a small, incredibly dense, and ferociously hot ball of matter at the star's center. But something curious is happening in the region around this collapsing core. Imagine a shell of hydrogen, the layer of fuel that was just outside the original furnace. This shell has, until now, been too cool to ignite. But as the core below it collapses and heats up to an incredible degree, it acts like a new, superhot stove burner. The heat pouring off the collapsing helium core is so intense that it ignites this surrounding shell of hydrogen. A new fire is lit. But this is not the gentle, steady fire of the star's youth. This is a frantic, furious blaze. This new hydrogen-burning shell is far hotter and burns far more intensely than the original core ever did. It produces a torrent of energy, a flood of light and heat that is vastly more powerful than anything the star has experienced before. This immense new wave of outward pressure begins to push on the star's outer layers, overwhelming the pull of gravity. And so, the star begins to expand. From the outside, what we witness is a slow, majestic, and terrifying transformation. The star, which has been a steady, yellow-white beacon for billions of years, begins to swell. It grows larger and larger and larger still. Its surface balloons outwards, stretching across millions of miles of space. If this were our own sun, it would first swallow Mercury, then Venus, and its fiery outer edges would lick at the atmosphere of the Earth itself. As the star's surface expands, its energy is spread out over a much larger area. This causes the surface to cool. The brilliant yellow-white light of its adulthood begins to dim and shift. It moves down the spectrum, from yellow to orange, and finally to a deep, luminous, and haunting red. The star has become a red giant. It is a beautiful but paradoxical creature. It is larger than it has ever been, yet its surface is cooler. It is more luminous, shining with a greater total brightness than before, yet its fire is the fire of old age. It is a star in its final, glorious act, a cosmic ember, flaring up one last time before it begins to fade. Life on any planets orbiting nearby would face an apocalypse. The gentle warmth of their sun has become a scorching, world-ending inferno. The sky would be filled with the immense, red orb of their dying star. It is a somber reminder that the same cosmic engine that creates the conditions for life will, in its final throes, also be the force that erases it. The star, now a red giant, is no longer in equilibrium. It has lost the peaceful balance of its youth. It is a creature of instability. Its interior is a chaotic place. The collapsing helium core at its center continues to shrink and heat up. The hydrogen-burning shell rages around it. The vast, bloated outer layers are tenuous and barely held on to by the star's gravity. The star pulses and throbs, like a weak and struggling heart. Its brightness can fluctuate as its internal battles rage on. It is a magnificent spectacle, a final, grand display of power. But it is the beginning of the end. The star has embarked on a new path, one that leads not to stability, but to dissolution. Its long, shining adulthood is over, and it has entered the twilight of its life. Section 5. A quiet, colorful farewell. Let us linger for a moment in the deep, ruby light of this red giant. The star is a magnificent, swollen ember, its peaceful adulthood a distant memory. It is a creature of deep instability, its internal balance lost to the ravages of time and the relentless pull of gravity. The furious hydrogen-burning shell continues to pour energy outwards, keeping the star's outer layers vast and bloated, a tenuous crimson ghost of its former self. But deep within, at the heart of the giant, The true drama is reaching its climax. The core, that sphere of helium ash, has been contracting and heating for millions of years. Squeezed by the crushing force of gravity, it has become incredibly dense. A teaspoon of this core material would weigh several tons. The temperature has been climbing relentlessly, past 50 million, 70 million, 90 million degrees. It is approaching a new critical threshold. The same threshold that was once crossed by hydrogen is now approaching for helium. And then it happens. At 100 million degrees, the helium nuclei, which have been resisting fusion for so long, can resist no more. In a cataclysmic, star-altering event known as the helium flash, the entire core ignites in a matter of minutes. In a silent, internal detonation, helium begins to fuse into carbon and oxygen. A new furnace is lit at the very heart of the star. This new burst of energy from the helium-fusing core pushes back against gravity, halting its collapse. A new temporary equilibrium is found. The star, which had swelled to its maximum size, now finds a moment of stability. It actually shrinks slightly and heats up, leaving the most extreme phase of its red giant stage. It has found a second wind, a brief reprieve from its slow demise. For a few million years, a mere cosmic heartbeat, it will quietly burn helium in its core, surrounded by the still ferocious shell of hydrogen fusion. But this reprieve is tragically short-lived. The helium fuel, compared to the vast ocean of hydrogen that came before it, is meager. It is consumed with furious speed. Soon, the helium in the core is also exhausted, leaving behind a new core made of carbon and oxygen. The furnace at the center goes out for a second time. And once again, gravity, the patient, ever-present force, begins to take over. The carbon-oxygen core, just like the helium core before it, begins to contract and heat up. This, in turn, ignites the shell of helium just outside the core. We now have an incredibly complex and unstable situation. A contracting carbon-oxygen core, surrounded by a shell of furiously burning helium, which is itself surrounded by a shell of furiously burning hydrogen. The star is now a cosmic onion, with layers of fire deep within its heart. The energy output becomes immense and violently unstable. The outward pressure once again overwhelms gravity, and the star begins to swell for a final time, becoming even larger and more luminous than before. It enters its final giant phase, a last, spectacular flaring of life. The star is now so large and its gravity so tenuous at its surface that it begins to lose its grip on its own outer layers. Great waves of pulsation, driven by the unstable fires within, ripple through the star. Imagine a colossal, beating heart, and with each beat, a great puff of its atmosphere is pushed out into the blackness of space. These are not violent explosions, but gentle, rhythmic exhalations. A series of cosmic smoke rings, puffed out every few 100,000 years. Layer by layer, the star sheds its skin. The beautiful, red-glowing gas of its outer envelope, enriched with the elements it has forged, is gently released. It expands outwards, a ghostly shell drifting away from the dying star at its center. This expanding cloud of gas is a gift to the cosmos, but for now it is dark and invisible. What remains of the star is the intensely hot, incredibly dense core of carbon and oxygen. The stellar furnace is extinguished forever. For a star of this size, there is not enough mass, not enough gravitational pressure, to ignite the carbon and oxygen into heavier elements. The long alchemical journey has come to an end. This exposed core is all that is left. It is a tiny, superheated object, blazing with a fierce, blue-white light. It is a newly born white dwarf. And now the final act of beauty begins. The intense ultraviolet light from this new white dwarf shines out into the expanding clouds of gas that the star just shed. The light acts like a cosmic lamp, causing the gas to ionize and glow with breathtaking colors. The invisible ghost becomes a vibrant, luminous entity. This is a planetary nebula. The name is an old historical mistake. They have nothing to do with planets. They are the final artistic signature of a dying star. From our distant vantage point, we see them as some of the most beautiful objects in the universe. They can take on fantastical shapes, rings, hourglasses, butterflies, eyes all sculpted by the stellar winds and magnetic fields of the star in its final moments. They glow with the iridescent pinks of hydrogen, the ghostly greens of oxygen, and the deep blues of helium. It is the star's final, quiet, colorful farewell, a masterpiece painted on the canvas of the void. This beautiful nebula will not last forever. Over the next few tens of thousands of years, the cloud of gas will continue to expand and disperse, its colors fading as it thins out and merges with the interstellar medium. The elements forged within the star are now returned to the cosmos, ready to be incorporated into the next generation of stars and planets. And at the center, the white dwarf, the star's tiny, dense corpse, will begin its own long, slow journey into darkness. It no longer generates any new heat. It is like a hot coal taken from a fire, and it will now spend an eternity simply cooling down, fading from brilliant white to yellow to orange to red, and finally, after a time longer than the current age of the universe, to a cold, dark crystal of carbon and oxygen, a black dwarf, a star's diamond tombstone, drifting silently through the eternal night. Section 6. The Path of a Titan. We have just witnessed the quiet, elegant end of an average star, a journey that culminated in a silent white dwarf and a beautiful, fleeting nebula. It is a graceful and gentle fading into the cosmic night. But not all stars are granted such a peaceful departure. Let us now rewind our cosmic clock. We return to that vast, cold nebula, the cosmic cradle where stars are born. We are going to follow a different path, a path of brilliance, of violence, and of ultimate transformation. This time, we focus our attention on a region of the nebula that is extraordinarily rich, a place where gravity's whisper is a commanding voice. Here, the protostar that forms is not merely gathering the mass of one sun, or two, or even five. It is a glutton. It pulls in gas and dust with ferocious efficiency, growing into a true titan of the cosmos. It gathers 8, 10, 20, even 50 times the mass of our own Sunday. The sheer weight of this immense gathering creates pressures and temperatures in its core that dwarf anything we have seen before. When this protostar finally ignites, it does not awaken as a gentle yellow star. It is born in a blaze of glory. It erupts onto the main sequence as a magnificent blue supergiant. It is a star of breathtaking power and beauty. It shines with a fierce, blue-white light, 100,000 times more luminous than our sun. It is a celestial diamond, a searchlight that can be seen across galaxies. But this brilliance comes at a terrible price. The star's life is a story of live fast, die young. The immense gravitational pressure at its core demands a truly colossal rate of fusion to maintain equilibrium. The star's nuclear furnace does not burn. It rages. It tears through its hydrogen fuel with an insatiable hunger. While our sun will spend 10 billion years on the main sequence, this blue supergiant will be lucky to last for 10 million. It burns through its vast reserves of fuel in a cosmic flash. Its entire lifetime is shorter than the time humanity has spent walking the earth. Let us feel the presence of this being. It is not a place of peace. The stability of our sun feels like a calm ocean. The stability of this supergiant feels like a perfectly balanced explosion, a continuous detonation held in check by its own immense gravity. Its stellar wind is not a gentle breeze. It is a gale. It blasts its surroundings with a torrent of radiation and high-energy particles, powerful enough to strip the atmospheres from any nearby planets and carve vast, empty bubbles in the nebula that birthed it. Life as we know it could never arise in the shadow of such a beast. The star is too violent, too intense, too short-lived. It is a star of pure, raw power, not of gentle nurturing. Its existence is a frantic race against its own inevitable collapse. Soon enough, in a mere few million years, the hydrogen in its core is exhausted. And just like its smaller cousin, the core begins to collapse. But for a star of this mass, the story unfolds on a much grander and more dramatic scale. The star swells not into a mere red giant, but into a red supergiant. This is a monster of truly mind-boggling proportions. If placed at the center of our solar system, a red supergiant like Betelgeuse or Antares would engulf the orbits of Mercury, Venus, Earth, Mars, and even the asteroid belt. Its outer edge would stretch out to the orbit of Jupiter, or perhaps even Saturn. It would be a star so large that if you were to travel across its diameter at the speed of light, the journey would take hours. The surface is a seething, chaotic landscape. The convective cells that churn beneath its surface are not the size of countries. They are the size of our entire Sunday. Great plumes of hot gas rise and fall over scales that defy imagination. The star is so bloated that its outer layers are incredibly tenuous, almost a vacuum, held together by a gravitational grip that is surprisingly weak at such a vast distance from the core. It pulses and throbs violently, shedding immense amounts of mass into the space around it, creating layers of dusty shells that shroud it in a celestial fog. And deep within this colossal, unstable body, the alchemical journey that ended with carbon in a smaller star is only just beginning. The collapse of the hydrogen-depleted core created temperatures and pressures so extreme that the helium flash was not a singular event, but a smooth and rapid ignition. The star quickly begins burning helium into carbon and oxygen. But it does not stop there. As the helium fuel runs out in a few 100,000 years, the carbon-oxygen core collapses. And unlike in a smaller star, the sheer mass of this titan is more than enough to ignite the next stage. Gravity squeezes the core until the temperature reaches a staggering 600 million degrees. At this point, carbon itself becomes fuel. The star begins to fuse carbon atoms together, forging heavier elements like neon, sodium, and magnesium. A new furnace is lit. A new, temporary stability is found. But this stage lasts for only a few centuries. When the carbon is gone, the core collapses again. The temperature soars to over 1 billion degrees. Neon begins to fuse. This lasts for about a year. Then the neon is gone. The core collapses. The temperature hits 1.5 billion degrees. Oxygen ignites, forging silicon and sulfur. This furnace rages for 6 months. The core collapses again. The temperature reaches 3 billion degrees. Silicon, the ash of the previous stage, begins to fuse. This is the final, frantic stage of stellar alchemy. In a complex and rapid series of reactions, the star burns silicon to create all the elements up to iron. This final, desperate stage of burning lasts for a single day. Think of it. A star that has lived for millions of years now has only 24 hours left. The heart of the star is a frantic, desperate engine, racing through its final fuel reserves, building layer upon layer of fusion shells. It has become a cosmic onion of unimaginable complexity. An inert iron core surrounded by a shell of silicon fusion, surrounded by a shell of oxygen fusion, then neon, then carbon, then helium, and finally a vast outer envelope of hydrogen. Each layer burns at a furious pace, a series of frantic fires keeping the beast alive for its final moments. The Titan has reached the end of its path. It has forged a heart of iron. And with iron, the journey of stellar fusion must come to an end. Section 7, The Cosmic Forge. Here we are, in the final day of a Titan's life. The red supergiant before us is a celestial ghost, a colossal, trembling sphere of gas so vast it defies comprehension. It breathes in and out, not with the gentle rhythm of life, but with the shuddering instability of its imminent death. Its deep red glow is the color of a fading ember, yet at its heart, a fire rages with more intensity than it has ever known. Let us not stay out here in the tenuous, dusty shroud. The real story, the final chapter of creation, is happening deep within. Let your mind slip past the vast, cool surface. We drift inwards, through an envelope of hydrogen so diffuse it is almost a vacuum, yet so immense it contains the mass of several suns. Deeper we go, and the temperature begins to rise. We pass through the first layer of the cosmic onion, the hydrogen-burning shell. This is the old, familiar fire, the same process that powered the star through its youth, now relegated to an outer province. It seems almost gentle compared to what lies beneath. We sink deeper, and the universe outside seems to fall away. We are inside a self-contained cosmos of pure energy. We breach the next layer, the helium-burning shell. Here, the temperature is over 100 million degrees. The fire burns with a hotter, cleaner intensity, a silent, blue-white inferno forging the carbon and oxygen that are so essential for the life that this star will never know. It is a profound act of cosmic generosity, performed in the star's dying moments. The pressure builds. We are being squeezed by the weight of a universe of matter above us. We push through into the next furnace. Here, at 500 million degrees, carbon itself is the fuel. For centuries, this layer has been the star's engine, creating the stuff of planets and atmospheres. Feel the vibration here. It is a deep, powerful hum, the sound of creation on a grand scale. The star is not merely burning. It is an alchemist, transforming the simple elements of the early universe into the building blocks of future complexity. It is taking the primordial hydrogen and, step by step, building a ladder of creation. Deeper still, the layers come faster now, their lifespans shrinking from millennia to years, to months. We pass through the neon-burning shell, then the oxygen-burning shell. The heat is now measured in the billions of degrees. The pressure is so great that matter ceases to behave in any way we would recognize. It is a sea of pure, incandescent potential. This is the heart of the forge. This is where the star performs its final, most astonishing work. We arrive now at the last creative fire, the silicon-burning shell. This furnace operates at a staggering 3 billion degrees. Here, in the final 24 hours of the star's life, the last great act of alchemy is taking place. The silicon ash from the previous layer is being slammed together with such unimaginable force that it fuses into heavier and heavier elements. Sulfur, argon, calcium all the way up the periodic table. This is the source. The silicon, the rock beneath your feet. The calcium, the strength in your bones, they were forged in a place just like this, in the last, desperate day of a dying star. It is a frantic, beautiful, and ultimately selfless act. The star is building a legacy. It is crafting the very materials from which new suns, new worlds, and perhaps one day new life will be built. It is a bridge between the sterile simplicity of the early universe and the rich, complex tapestry of the cosmos we know today. And as we watch this final, frantic fire, we see the ash it produces. It is the final product of this long fusion chain. This ash is iron. Let us sink through this last, raging fire into the very center of the star. We have arrived at the core. It is a sphere of pure iron, growing larger by the second as more of this ash rains down from the silicon-burning shell above. But something is wrong. This place is quiet. The creative hum is gone. The furnace is out. The iron core is inert. Here, the star has encountered a fundamental law of the universe. It has hit a wall. To understand this, you must understand the gift of fusion. Every fusion reaction up to this point, from hydrogen to helium, from carbon to silicon, has been an act of giving. When two lighter nuclei merged, the new, heavier nucleus they formed contained slightly less mass than the original two combined. That lost mass was given back to the star as a gift of pure energy. This energy, this light, is what held gravity at bay for millions of years. It was the star's life force. But iron is different. Iron is the most stable, most perfectly bound atomic nucleus in the universe. It is the celestial lock. It is so perfectly balanced that if you try to fuse it into something heavier, the process doesn't release energy. Consumes it. It steals heat and energy from its surroundings. The star's heart, the engine that has pushed outwards for its entire life, has suddenly turned into an energy vampire. Trying to fuse iron is like throwing a bucket of water onto a fire. It doesn't just fail to burn. It actively quenches the flames around it. The fire at the very center of the star has gone out, and it will never be lit again. The gift of energy has stopped. The outward push, the star's very soul, has vanished. For the last few minutes, the only thing holding up the immense weight of the star is the quantum pressure of the electrons in the iron core, a final, fragile scaffolding against the inevitable. But the silicon shell continues to burn, dumping more and more iron ash onto the core. The core grows heavier, denser, more massive. 1.1 solar masses, 1.2, 1.3, it is approaching a critical limit, a point of no return. The heart of the star is now a dead weight, a ticking time bomb of gravity. The balance has been irrevocably broken. The pillar supporting the entire, colossal structure has crumbled to dust. Everything is poised, for a fraction of a second, in a moment of terrifying, silent stillness before the fall. Section 8, the Great Cosmic Recital. We are suspended in the final, silent microsecond. The iron core at the heart of the supergiant has grown too heavy. The fragile electron pressure that held it up against its own gravity has failed. There is now nothing, absolutely nothing left to resist the crush of the star's own immense mass. The time bomb has reached zero, and the star begins to die. The iron core, a sphere larger than the Earth, collapses. It does not shrink slowly. It implodes. In less than a quarter of a second, it falls in on itself at unimaginable speed. The outer edge of the core plummets inwards at nearly a quarter of the speed of light. A sphere the size of a planet collapses down to the size of a city. This is not a structural failure. It is the failure of space and time itself. The very fabric of the universe is being crushed. As the core implodes, the atoms within it are shattered. The immense pressure is so great that it overcomes the forces that hold atoms together. Electrons are rammed with such violence into the protons of the iron nuclei that they merge, forming a new particle, a neutron. The core is transformed into a seething, superdense ball of pure neutrons. The positive and negative charges that once defined the matter have been extinguished, leaving behind a neutral, ghostly substance. This process releases a flood of tiny, ethereal particles called neutrinos, which fly out of the core, carrying away a tremendous amount of energy. The collapse is not infinite. When the core has been compressed to this state of pure neutron matter, a substance so dense that a single sugar cube of it would outweigh all of humanity, it can be compressed no further. A new, powerful quantum force, the neutron degeneracy pressure, awakens. It is like hitting the most rigid, unyielding wall in the universe. The core, which was imploding at a quarter of the speed of light, slams to a halt. And then it rebounds. The core, having hit this unyielding wall, bounces back. It recoils in a shockwave of monumental power. This shockwave, a titanic pulse of pure force, begins to race outwards from the center of the star. At the exact same moment, the layers of the star above the core, the silicon, the oxygen, the carbon, all the way out to the vast hydrogen envelope are in freefall. They have lost their support, and they are now plummeting inwards, accelerating into the void left by the collapsing core. The outward-moving shock wave and the inward-falling matter are on a collision course. They meet in a cataclysm of unimaginable proportions. The shock wave slams into the infalling shells of gas with the force of 1 trillion nuclear bombs. For a moment, it looks like the shock wave might stall, its energy absorbed by the immense weight of the infalling material. But then, the flood of neutrinos that was released from the core arrives. Although neutrinos rarely interact with anything, the sheer density of the plasma is so great, and the flood of neutrinos is so immense, that they dump a colossal amount of extra energy into the shock wave, re-energizing it, giving it the final violent push it needs. The battle is won. The rebound shock wave overpowers the infalling matter and begins to drive it outwards. The star, which was in the process of imploding, now begins to explode. This is the supernova. The shock wave tears through the star's layers at incredible speeds. As it passes, the heat and pressure are so intense that they trigger one last, final frenzy of fusion. This is not the slow, patient fusion of a star's life, but the chaotic, violent fusion of its death. In these few seconds, all the elements in the universe heavier than iron are created. The gold in a wedding ring, the silver in a coin, the uranium in the earthall were born in the heart of this final, desperate scream of light. The star, in its last act, completes the periodic table. The blast wave finally reaches the surface, and the star detonates. In a single instant, it becomes brighter than 1 billion suns. It shines with more light than its entire host galaxy combined. If a supernova were to occur where the nearest star to our sun is, it would be as bright as the full moon in our sky, and it would cast shadows at night. It is the most violent, most luminous event the universe can create. A great cosmic recital, a final, deafening chord played on the strings of space-time. The entire body of the star, all those layers of hydrogen, helium, carbon, oxygen, and the newly forged heavy elements is blasted outwards into space. It becomes a glowing, expanding cloud of debris, known as a supernova remnant. This cloud travels outwards at millions of miles per hour, a celestial tsunami carrying the building blocks of life and the treasures of the cosmos out into the interstellar medium. The star is gone. It has sacrificed itself. But its death is not an end. It is a beginning. It has seeded the universe. The cloud of enriched gas and dust will travel through the galaxy for millions of years, mixing with other clouds, enriching them with the heavy elements it carries. This legacy, this gift of a completed periodic table, is what makes future worlds like ours possible. Our planet, our bodies, the iron in our blood, the calcium in our bones, the oxygen we breathe are all made of stardust. We are the children of supernovae. The Titan's violent death is the universe's ultimate act of creation. Section 9. Echoes in the darkness. The great recital is over. The final, deafening chord of the supernova has faded. Its light now a rapidly expanding, ghostly cloud of incandescent gas. The spectacle, which for a moment outshone a galaxy, is now a beautiful, dissipating memory. The debris cloud, rich with the treasures of the cosmic forge, begins its long, slow journey into the interstellar night, a gift to a future generation of stars. But our journey is not with the cloud. Let us turn our attention back to the epicenter, back to the scene of the cataclysm. What was left behind when the star tore itself apart? What echo remains in the darkness where a Titan once stood? Let us drift back to that central point. In the aftermath of an average supernova, where the original star was massive, but not a true behemoth, something extraordinary remains. We find the star's collapsed core. the sphere of iron that fell in on itself and then rebounded, triggering the great explosion. It is no longer iron. It is no longer familiar matter. It is a neutron star. Approach it in your mind, but with caution. It is one of the most extreme objects in the known universe. The first thing you would notice is its size. It is impossibly small. A star that was once millions of miles across has been crushed into a perfect sphere no larger than a city. A mere 12 miles from one side to the other. It is a celestial tombstone, a monument to a dead star, yet it is anything but dead. It has the mass of 1.5 suns, all compressed into that tiny volume. The gravity here is not just strong. It is reality-bending. A gentle-seeming mountain on its surface would be no more than a few inches high, yet its peak would exert a gravitational pull billions of times stronger than Earth's. Light itself has to struggle to climb away from its surface. It is the ghost of a star, retaining all the weight of its former life, but none of the size. And it is spinning. When the vast, slowly rotating core of the supergiant collapsed, it brought its spin with it. Think of an ice skater, spinning slowly with their arms outstretched. As they pull their arms in, their spin becomes blazingly fast. The neutron star has done the same on a cosmic scale. It rotates not once a day or once an hour, but hundreds of times every single second. A city-sized object, heavier than the sun, spinning faster than the blades of a kitchen blender. This rapid spin, combined with the star's original magnetic field now compressed and amplified to 1 trillion times the strength of Earthshaw's, turned the neutron star into a colossal cosmic dynamo. It generates stupendous beams of energy, radio waves, and X-rays that shoot out from its magnetic poles. And as the star spins, these beams sweep through space, like the beam of a celestial lighthouse. If you happen to be in the path of one of these beams, you see a pulse of energy every time the star rotates. A rhythmic, metronomic beat. We call this a pulsar. It is the universe's most perfect clock, a rhythmic heartbeat in the silence, the enduring pulse of a star that has long since died. But what if the original star was even bigger? What if it was a true monster of the cosmos, 30, 40, or 50 times the mass of our sun? What happens then? Let us revisit that final, fatal moment of collapse. The iron core implodes. It crushes down into a ball of neutrons. But this time, the weight of the star above it is too great. The force of gravity is simply overwhelming. The neutron degeneracy pressure, that unyielding wall that triggered the bounce in a smaller supernova, is not enough. The wall breaks. Gravity wins. It wins absolutely. The collapse does not stop. The core continues to shrink, past the size of a city, past the size of a house, past the size of a marble. It crushes itself down to a point with no dimensions at all. A point of infinite density and zero volume. This is the singularity. The laws of physics as we know them break down here. It is a point where our understanding ends, a scar on the very fabric of spacetime. The star has collapsed into a black hole. We cannot see it. A black hole emits no light, no heat, no radiation. It is the ultimate darkness. What we can perceive is its effect on the space around it. The immense gravity of the singularity bends spacetime so profoundly that it creates a one-way boundary around itself. This is the event horizon. Do not think of it as a surface you could touch. It is not a black sphere. It is a threshold of no return. Imagine it as the edge of a great cosmic waterfall. If you are a boat far upstream, you can still steer away. But once you drift past the edge of the falls, no amount of paddling, no engine, can save you. All paths lead down. The event horizon is the edge of that waterfall in spacetime. Once anything a beam of light, a particle of dust, a wandering planet crosses that boundary, it can never escape. Its future contains only one destination: the singularity at the center. A black hole is not a cosmic vacuum cleaner. It does not roam the galaxy sucking things in. It is a passive, patient predator. It simply sits, its immense gravity warping the space around it, and waits. Anything that strays too close is caught in its gravitational well, beginning a long, slow spiral towards the event horizon. To the universe outside, it appears as a perfect sphere of blackness, a hole in the heavens, its silhouette visible only against the background of distant stars whose light it blocks. It is the final, silent, and eternal remnant of the most massive stars, a point of infinite mystery from which no information can ever return. So from the death of Titans, the universe leaves behind one of two echoes: a pulsar, the hyperdense, spinning heart of a dead star, beaming a rhythmic pulse of life across the cosmos; or a black hole, the ultimate victory of gravity, a silent, dark enigma that challenges the very limits of our knowledge. One is a beacon, the other a void. Both are the final, profound statements in the life cycle of a star. Section 10. The dust of stars returns. The supernova is gone. Its impossible light has faded. Its thunderous roar has fallen silent. All that remains is the expanding cloud of its own being, a celestial ghost pushing outwards into the void. This is the star's legacy. It is not just gas. It is a treasure chest, flung open for the cosmos to share. For thousands of years, this remnant cloud glows with a haunting beauty, a filigree of intertwined light and shadow, a final, intricate tapestry woven by the dying star. It is a spectacle for the universe to witness, a memorial to the Titan that was. But as millennia turn into hundreds of thousands of years, the cloud cools. The brilliant colors fade. The glowing gas, now spread thin across light years of space, becomes dark and cold once more. It is no longer a spectacle. It is a quiet, invisible presence, drifting on the slow, patient currents of the galaxy. It is a cloud of memories, carrying the iron from the star's final heartbeat, the oxygen from its long adulthood, the gold and silver forged in the final, fiery scream of its death. This cloud does not journey alone. It encounters the vast, ancient oceans of hydrogen that have drifted between the stars since the dawn of time. And as it moves through them, it mixes. Imagine a drop of the richest, most complex ink falling into a vast glass of clear water. The ghost of the supernova dissolves, sharing its treasures, enriching the primordial clouds with its hard-won elements. The sterile, simple gas of the early universe is now seeded. It is salted with the potential for complexity. These interstellar clouds are no longer just cosmic nurseries. They have become fertile fields. And so, our journey comes full circle. We find ourselves back where we began, floating in a vast, dark, and beautiful nebula. But this is not the same nebula we first visited. This one holds a secret, carries the legacy of the Titan. It is rich with carbon, with oxygen, with silicon, with iron. It carries the complete alphabet of cosmic creation. Once again, the whisper begins. Gravity, the patient sculptor, sees this enriched cloud and begins its slow, gentle work. It murmurs its invitation, and the dust and gas begin their long, slow dance. Clumps form. A new protostar begins to coalesce at the heart of a spinning disk. But this time, the disk itself is different. It is not just hydrogen and helium. It is a thick, churning soup of all the elements the supernova bequeathed to it. As this new protostar gathers its strength, glowing with the deep red promise of a new life, the material in the disk around it begins its own journey of creation. The tiny grains of silicon and carbon, memories of the dead Titan, begin to stick together. Electrostatic forces, like the crackle of a warm blanket on a dry night, pull them into larger and larger clumps. Dust becomes pebbles. Pebbles collide and merge, becoming rocks. Rocks crash together to form boulders, then mountains, then planetesimal seeds of worlds. A new solar system is being born. And unlike the first generation of stars, which were likely orbited by only gas giants, this new star has the ingredients to form solid, rocky worlds. A planet begins to take shape, a sphere of cooling rock, rich with iron that sinks to form its core, and silicates that form its mantle and crust. The lighter elements, the gases released by this new, young sun, form an atmosphere around it. Water, trapped in asteroids and comets themselves remnants of this messy creation process, crashes down onto the new world, delivering the oceans. A new star shines in the darkness. It is a second-generation star, a child of the ashes. And orbiting it is a new world, a blue and white marble, teeming with potential. A world made from the body of a star that died so that it could live. The iron that was forged in the supergiant's final day now forms the core of this new planet, creating a magnetic field that will shield its surface from the harsh stellar winds. The carbon, created in the helium-burning shell, is now the backbone for any complex molecules that might arise. The oxygen, the gift of the star's long life, now fills its oceans and its sky. The life cycle is complete, not as a closed loop but as an upward spiral. Death has led to rebirth, but the rebirth is richer, more complex, and holds more potential than what came before. The universe has learned. It has folded the experience of one star's life and death back into itself, creating the conditions for something new, something wonderful. The violent death of the Titan was not an end. It was the planting of a garden, a quiet, patient, and magnificent act of cosmic preparation. And so, our long journey through the life of a star comes to a gentle close. We have drifted from the silent dust of a cosmic cradle to the brilliant fire of a stellar heart. We have witnessed the quiet, colorful farewell of one star and the glorious, universe-altering sacrifice of another. We have seen how in the cosmos, nothing is ever truly lost, but is instead transformed, recycled, and reborn into something of even greater promise. The story of the stars is our own story, written on the grandest of all scales. The carbon that dreams in your cells, the oxygen that fills your lungs with each slow breath, the iron that carries that life through your veins, all were forged in the heart of a star that lived and died long before this earth was ever formed. You are, in the most literal sense, stardust awakened. You are the universe's way of witnessing its own magnificent beauty. Now, let this cosmic perspective bring you a deep and profound peace. Let the vastness of space hold you. Let the silence of the void quiet your mind. There is nothing left to do but to let go and drift into the peaceful darkness. May your dreams be as vast and beautiful as the nebulae we've explored. Sleep well, child of the stars.